All right, let's begin with this review. Ladies and gentlemen, let us look at question number 1, where the question asks, which expression does not represent this model? Well, what do we have here in this model? Well, we see, let's start with the highest exponent on the variables. So we see that we have 1, 2, 3 of the x squared. So I can write that as x squared plus, and that looks really ugly. Let me try that again. I can write that as x squared plus x squared plus a third x squared. So ladies and gentlemen, that is basically 3 x squareds. All right, there's 3 of the x squared. That's exactly what that means. Plus, notice that we have 1, 2 of these rectangles with x's. That's going to be plus x, or we can say plus 2 of the x rectangles here. And then finally, ladies and gentlemen, we have plus 1 plus another 1 plus another 1, because we have 1, 2, 3 of those little 1 boxes. So we can say plus 3. All right, so they may not look exactly like these, but 3 of these choices look will have the same meaning as either of these 2. There's one that does not represent that model, and it is up to you to figure out which one that is. All right, I'm going to be moving pretty quickly, so let's go on to the next one. Ladies and gentlemen, on the second one, on number 2, we are given the following expression: 9 parentheses n minus 5 close parentheses minus 4. And we want to know which of these 4 is the same as that expression. Well, ladies and gentlemen, remember that we read this from left to right. So reading it from left to right, this literally means that we're going to do 9 times all of this times n minus 5. And then whatever I get minus 4. All right. Normally, when we do PEMDAS, we would do whatever's inside the parentheses, but how can I take away 5 from n when I don't even know what n is? Instead, ladies and gentlemen, we can just think of this as doing n minus 5 9 times. In other words, n minus 5 plus n minus 5 plus n minus 5 plus n minus 5. And again, we're going to do that 9 times. And when we do that, we're going to see that we have 9 n's, right? Or we can follow this pattern, the very same pattern that we saw when we were looking at the distributor property. I can distribute the 9. I can distribute the 9 to both of the terms inside of the parentheses. So 9 times n minus 9 times 5. If you see your notes, you should be familiar with that pattern. You should follow those arrows. All right, so 9 times n is going to be 9n minus, because we have a minus sign, 9 times 5, which is 45, but I'm just going to write 9 times 5. 9 times 5, and then minus 4. Okay, and notice that over here, they don't fully work out any of these. And so let's just figure out which of those is closest to this. So notice that all of them start off with 9 times n, okay, which makes sense. That's exactly what I have here. And then we have minus, so it should be a minus, which eliminates b and c because they have plus signs. So we have minus, minus. And this is 9 times 5. 9 times 5 is up here. 9 times 5 is down here. Good. And then it should be minus 4. Here it says minus 9 times 4. That is incorrect. It should just be minus 4. So notice how the difference seems subtle, but it is clear, guys, that we just have 9n minus 9 times 5 minus 4. All right, moving on to the next one, ladies and gentlemen. I know I'm going quickly, and if I'm going too fast, I recommend you pause the video, rewind it, watch it again. Continuing, ladies and gentlemen. Oops. Let's do this. Okay. Continuing. We are given the expression -3 to the third power minus 16 divided by 4. Well, ladies and gentlemen, notice that whenever we have we're taking this to the third power, it is outside the parentheses, meaning that all of this, everything inside the parentheses, must be taken to the third power. So remember that just means repeated multiplication. So I'm going to multiply everything inside the parentheses, which is -3, times itself 3 times. That's what this means. And whenever I do that, notice that I have to use what I know about multiplying with negative numbers. So we have -3 times -3, which we should remember that when we multiply and there's the same signs, the answer is always going to be positive, or I can use the fox. Notice that we have a -3 times a negative 3. So the answer should be positive 9. But I still need to multiply that times this negative 3 right here. Now, ladies and gentlemen, let me do the Fox again. And notice that I have a positive 9 times a negative 3. So my answer should be negative 27, leaving me with negative 27 minus 16 divided into 4. Continuing, ladies and gentlemen, notice that I have subtraction and division. What must I do first? Obviously, I must divide. So 16 divided by 4, which you should know is 4. And now I'm going to bring everything down. Negative 27 minus 4. Now, I know you're going to be tempted to work this out, but ladies and gentlemen, let me remind you that we do not like to subtract with negative numbers. Instead, we're going to change our perspective, not change the problem, but change our perspective from a subtraction perspective to an addition perspective by using the acronym KEEP, CHANGE, CHANGE. So I'm going to keep the negative 27, change the subtraction symbol to an addition symbol, and then change the 4 to a negative 4. All right, so again, I kept the negative 27, I changed the subtraction to addition and changed the 4 to a negative 4. So now we can clearly see that we are simply combining 27 negatives with 4 negatives. They're both going in the negative direction, so they are helping each other out. So just add them together, which brings us 31 and in the negative direction because they're both negative. 27 negatives plus 4 more negatives gives us 31 negatives. So that would give us our answer. Again, ladies and gentlemen, it is not about the answer, but it's about understanding how we got there. You're not going to have this video or myself to help you during the quiz. So please, if you miss something, I recommend you rewind it and see if you can understand the process. Continuing with our next one. Right here, it says determine the value of this expression. Ladies and gentlemen, one word, PEMDAS, okay? Make sure that you follow PEMDAS, parentheses, followed by the exponents, followed by either division or multiplication, depending on which comes first, and then finally subtraction and addition, again, depending on which comes first from left to right. So I'll let you do number 4 on your own. Moving on to number 5. Number 5 reads, write an algebraic expression to represent the following statement. 12 divided by a number n, subtracted from 50. Okay, so we have 12 divided by a certain number, which is n, subtracted from 50. Subtracted from 50. So it seems to me that we're going to take something away from 50. So ladies and gentlemen, I have to start with that 50. So it's going to be 50. What are we going to subtract from 50? Well, we're going to subtract, so here's the subtraction symbol. What is 12 divided by a certain number n? So typing this in, ladies and gentlemen, I can see that it's going to be 50 minus 12 divided by n. Now, from what I've seen, a lot of people do the exact opposite. They start off with 12 divided by n, and then they subtract 50. That is not the same thing, ladies and gentlemen. We're not subtracting by 50. We're subtracting from 50. What are we subtracting from 50? 12 divided by n. 12 divided by n. So that is the answer with no spaces. Moving on, ladies and gentlemen, to number 6. Number 6 says, evaluate the expression for the given value. So normally, not normally, but oftentimes in this section, what we would do is that we would take 2, and then we have h squared plus 5, and simply given that expression, we could use the distributive property. I could multiply 2 times h squared and then add 2 times 5, and that would leave me with 2h squared plus 10. However, that is not what this is asking, because when I keep reading, I can see that it tells me what h is. It says where h is equal to 3. Meaning that I can start over and I can just replace, I can substitute all the h's with a number 3. So instead of 2h squared, I'm going to have 2, parentheses, 3, because I'm replacing the h with a 3, squared, which is to the second power, plus 5. And now, ladies and gentlemen, I am free to just use PEMDAS. All right, so we have 3 squared, because we're doing the parentheses, and inside the parentheses, we do the exponent. That is 3 times 3, so that's going to be 9. So that's going to be 2 times 9 plus 5. Again, I have to add before I multiply. So 9 plus 5 is 14. So that leaves me with 2 times 14. And ladies and gentlemen, 2 times 14 is 28. That would be my final answer. So again, if they give you the value for the variable, then just apply that, substitute all the variables with that given value, and then just use PEMDAS again. Just use PEMDAS. Moving on, ladies and gentlemen, to question number 7. Question number 7. Simplify the expression, okay? Combine like terms, see where you can do things. So let's just rewrite it. So we have 12 times 2x plus 1, close parentheses, minus 3x plus 7. Plus 7. All right, so using PEMDAS, ladies and gentlemen, I normally would focus inside the parentheses, but I cannot add 1 to 2x. They don't have the same variable. They don't have the same power. But notice that this means multiplication. So multiplication, I must do that. And what am I going to multiply? Well, use the distributive property, 12 times 2x and 12 times 1. So let's go ahead and do that first. 12 times 2 is 24x plus 12 times 1, which is 12, minus 3x, just bring everything down, plus 7. All right, continuing, ladies and gentlemen, notice that we have x's and we have numbers without any variables. So let's go ahead and do that. Let's go ahead and do 24 minus 3x. Now, what I saw is that a lot of people were adding 24 and 3x, being like, well, isn't that a positive 3x? Ladies and gentlemen, if you are at a loss, if you're not sure, then just try the opposite. What if it did say plus 3x? Oh, well, then it definitely makes sense that it would be 24x plus 3x, which would be 27x. But it doesn't say plus 3x. It says minus 3x. So clearly, it cannot be the same answer. So it's going to be 24x minus 3x, which is going to give me 21x. And then plus 12 plus 7 is 19, so 21x plus 19. And that's exactly what I would type in. I would type in 21x plus 19. Make sense? All right, moving on. Ladies and gentlemen, question number 8 right here shows me the following. It's the same thing, ladies and gentlemen. We have 3.3 parentheses x plus 4, close parentheses, minus 2x. Same thing, I cannot add 4 and x, but I can multiply. I can multiply 3.3 times x, and I can multiply 3.3 times 4. So 3.3 times x is just going to be 3.3x, and 3.3 times 4, if you don't know what that is, just work it off here on the side. 4 times 3 is 12. 4 times 3 is 12, plus 1 is 13, and we have one decimal place, so that's going to be plus 13.2 minus 2x. Moving on, ladies and gentlemen, now let's combine the like terms. We have 3.3x minus 2, which when you line up the decimals, that would give me 1.3x plus 13.2, which indeed is the simplest that I can go, so that would be my final answer. 1.3x plus 13.2. Finally, ladies and gentlemen, finally, we have question number 9, which says fill in the table, but this time they give us a value of x. This is exactly what we did recently, where instead of the x, I'm gonna replace it with, I'm gonna substitute it with the given x value. So here, both of these, I'm gonna replace the x value right here and right here with the number 3. All right, so here we have 3 times 3, because that's the x, plus 6, and over here we have 3 parentheses 3 plus 2. Again, notice that all I did is I replaced the x with the given value. So here it says x equals 3, so that's why I put a 3 right here and a 3 right here. Let's work it out. Well, 3 times 3 is 9, plus 6 is 15. 3 plus 2 is 5, times 3 is 15. So they are the same so far. Let's test the next one. The next one says 3 times 5 plus 6, and then we're going to have 3 parentheses 5 plus 2. Whenever I work these out, ladies and gentlemen, I can see that 3 times 5 is 15 plus 6. I can't think, it's 21, sorry, 21. And here, 5 plus 2 is 7 times 3 is 21. So again, they are the same thus far. And those are the answers that I will be putting in the blanks. So try the last one for x. Instead of x, you're going to use 7. See if they're the same. And then finally, you're going to type in capital Y for yes, they are equivalent expressions, or N for no, they are not equivalent. All right, ladies and gentlemen, I hope that you found this video helpful. And again, if I was going too fast, which I probably was, Go back, review each problem, the ones you had trouble with, and watch it several times if you have to. And with that in mind, ladies and gentlemen, I will see you next time.